All right, we're back to looking at part 2 of using linear models. So earlier we learned about how correlations are related, whether they're positive or negative, whether they're closer to 1 or negative 1 or closer to 0. Remember, the closer they are to a line, the closer they'll be to negative 1 or positive 1. The farther apart they are, the closer it'll be to 0, that R factor. So I did the liberty of kind of cheating and writing down everything that you had here, all this information. So the first example, looking at your notes, was the temperatures throughout the year and the monthly bill we had to pay for our heating or cooling bill. So the way I made this, I started with 55, went up by 5s on the bottom for average temperature. For the utility bill, I started at 110 and went up by 20s. You can do this however you want, however it fits your graph. So, looking at this and plotting these points, I start with 61 as my average temperature, then it goes up to 150. So there's January right there. February is 58 and 139. March is 67 and 172, which is here. April is 75 and 205, which is up here, and so forth. And I kind of mapped out or plotted all my points on my coordinate plane. Now I kind of put my circle around it, and I draw a line right through the middle of my data to kind of help, and hopefully it kind of cuts right through the middle of it. Some are going to be above it, some are going to be below it. So again, my circle is kind of thin, so I think it's going to be closer to 1 than it is to 0. So I'm going to guess that my R value is a positive 0.7. It's positive because the slope is up and it's kind of close together. So I would think there is a relationship between the average air temperature outside with how much we're going to pay in electricity, cooling, or heating our house. If we look at number 2, there is a definition that I want you to write down. It's a trend line. So a trend line, again, is a line that goes through the middle of our data. It's not going to touch every piece, it just goes in the middle. And what the trend line is, and I want you to write this down, okay? It is an approximate line to represent two variables of data. So we can come up and write an equation to kind of represent of what we expect our utility should be on an average year. Okay? So with that trend line, and you can copy that down. If you need to pause the video, you can. So if we're looking at this, I could say when the temperature is 75 degrees, I might guess to be paying about $190 in my bill. If it's $100, if it's 100 degrees, I can expect to pay close to $290 a month if I continue my line. If it's 65, I can expect to pay about $145. So I can estimate, and businesses do this all the time. Forecasters do this all the time. Right? They look at different data and make their best guess on what it will be. So the second problem I want to go over, and this is about the Florida median home prices going back since 1940. So the number of years since 1940. So my years are going to be on my x-axis down here. Okay? And again, I'm starting with 1940. It's my starting year. All right? And I'm going up by 10. 1950, 1960, 70, 80, 90, and 2000. Making it nice and easy. All right? Ignore that. I don't know what that is. Going up here, the median price, it started at $20,000. And I went up by $10,000 each year up to $110,000. And then I plotted my data. 1940 was $20,000. 1950, it was $40,100. And I went up all the way up to 2000 when we got up to $105,500. Now, drawing a circle around my data, again, it's pretty close together. And I drew a trend line kind of looking at it, it was a little off. Probably could have been a little higher, but that's okay. That's my trend line. And I would expect my R value to be about positive 0.8. So again, the trend is that the values are going to rise. Now they don't rise every year. If you see, from 1960 to 1970, it actually went down in price. And it very rarely happens in real estate, but it does. It happened back about 12 years ago too, where there's a big dip in the housing market. But again, eventually it does bounce back. So from this, I sketched a trend line. Now, we want to come up with an equation to represent this. Now, you can come up with a different line, and we're going to do a lot of practice with these over the next couple days. But I want to pick 2 points here. Now, it just so happens that maybe the points I want to use, I want to start with my y-intercept here and this point right here. My first point, my last point. It doesn't have to be like that. It just worked out like that. Worked out nice for me. So I can come up with an equation now. Now, how can I do this? I want to make sure we can still see this and see this. Now, with those points, we know if we have 2 points, we can come up with a line. We did this in our last section. So our first point is the years. How many years since 1940 are we? We are 0 years from 1940. We're right on our y-intercept. So that's 0. And our amount was $20,000. The next point we used was over here. This was the year 2000, but it was 60 years since the year 1940. Again, this is since 1940. So 60 years later, and we're at 105,500. So, first thing, we have to get our slope. Remember slope formula. y2 minus y1 divided by x2 minus x1. So 105,500 minus this is 85,500 divided by 60. Now, I'm not that good to do my math. So I'm going to do it off to the side because it's quicker than finding a calculator. It's going to go in once. 25. It's going to go in 4 times. It's going to go in twice. So it comes out to 1425. So my M value is 1425. Now, what else do we know from this? I know we know 2 points, but this is a special point. This is our y-intercept. So, from this graph, I can come up with a line of best fit or a trend line. Okay? So our trend line or line of best fit and I'll kind of go back and forth with calling it this. Y equals my M value is 1425x plus 20,000. That was our y-intercept. And there's our fit. If we didn't know that, we could do y minus y1 equals our slope times x minus x1. And we can get it that way get that as well. So, there's our line of best fit from our original graph. And those are 2 good examples of looking at our trend lines, looking at our R values, and looking to see how correlations are established. Have a great day.